In this video, we're going to talk about limits and continuity. First, let's talk about limits. So, a limit helps us to understand the behavior of a function as the input approaches a certain value. So, it's like predicting the destination of a car based on its current path. Now, so mathematically, we can write a limit as lim x arrow a then f of x. Now this is read as limit of f of x as s approaches a. That's how it is read. Now let's solve some basic limit problem. So consider the problem f of x being equal to 2x plus 3. Now let's find the limit as s approaches 2. So the first thing that we need to do is to substitute the value of x into the function. So as s approaches 2, so f of 2 is equal to 2 open bracket 2 plus 3, and f of 2 is equal to 4 plus 3. F of 2 is equal to 7. Right. So lim f of s as s approaches 2 is 7. Now, let's solve another one. So we are going to find the limit as s approaches 3 for the function. So let me go to the next page. So f of x equal to x squared minus 1 as s approaches 3. So just substitute the value of x into the f of s or into the function. So we have f of 3 equal to 3 squared minus 1. So f of 3 is equal to 9 minus 1. F of 3 is 8. So the limit of f of s as s approaches 3 is 8. Now next, let's talk about continuity. So a function is continuous if you can draw its graph without lifting your pen. So this means that the function has no breaks, jumps, or holes. So mathematically, we can describe it as the function f of s is continuous at a point of s. So f of s is continuous at a point x equal to a. Now, if first the function is defined at x equal to a, second, if the limit as s approaches a exists, so if a as s approaches a exists, and thirdly, if the limit equals the function value at a equals a. So let's take some practical examples. So let's determine if the function f of x equal to 3x minus 4 is continuous at x equal to 2. So the first thing we need to do is to check if f of 2 is defined, as we stated earlier on. So f of 2 here should be 3, 2 minus 4. So f of 2, that is 6, 4. So f of 2 is 2. Now the next step is to find the limit as s approaches 2. So you can follow those steps that I stated earlier on. So we find the limit as s approaches 2. So the limit as s approaches 2, so that'll be So that will be f of 2 being equal to 3 multiplying 2 minus 4. So f of 2, that is 6 minus 4. So f of 2 being equal to 2 as x approaches 2. So since both the limit and the f of 2 are equal to 2, the function is continuous at x equal to 2. Very easy. Now let's take some series of examples. So our first example, so let's say we are going to find the limit as s approaches 4 of the function f of x equal to s squared plus 2x. And question 2, let's say we are going to determine if this function f of x equal to s squared minus 4 is continuous at x equal to 2. So you can pause the video and give them a try. So let's go over this solution. So first of all, we have to find a limit as s approaches 4 for the function f of x being equal to s squared plus 2x. So we substitute x equal to 4 into the function. So we have f of 4 equal to 4 squared plus 2 multiplying 4. So we have 16 plus 8, and we have 24. So let the limit as s approaches 4 is 24. Very easy. Now the next one, so this question 1, question 2, I hope you got it. So the next one, we are going to determine if the function f of x equal to s squared minus 4 is continuous at x equal to 2. So we'll go through step by step. Now we have to check if 2 or f of 2 is defined. So f of 2 should be equal to 2 squared minus 4. So we have 4 minus 4. So f of 2 is 0. Now the next step is to find the limit as s approaches 2. So that's lim x approaches 2. So f of x, which is the equation s squared minus 4. And we will have f of 2 being equal to s, that's 2 squared minus 4. So we have 4 minus 4, and we have 0. So the function f of s, which is equal to s squared minus 4, is continuous as s equal to 2. Now let's take more practice questions to test our skills. So let's say we are going to find the limit x. So let's take this example here. So we are going to find the limit as s approaches 1 for the function. So lim as s approaches 1 for the function 5x minus 2. Right? So we go step by step. So here we have f of 1, 5 multiplying 1 minus 2. So f of 1 is 5 minus 2. So f of 1 is 3. Very easy. And now let's determine the next one is let's determine if the function f of x equal to the absolute value of x is continuous at x equal to 0, right? So first we have to find the limit as s approaches 0 from the left and right. So that will be the lim x approaches 0, absolute value of x, and this one is equal to 0. Now we have to find the limit as s approaches 0 from we have to check if it is defined for the next one. So we have f0, then absolute value of 0, which is 0. Therefore both sides is equal to 0, then therefore the function is continuous at s equal to 0. Now let's take that example. Now we are going to find the limit as s approaches -1 for the function f of x s cubed plus s squared as s approaches -1. So f of -1 is equal to -1 cubed plus -1 squared, and we have -1 plus 1, we have 0. So f of -1 is 0. Now let's take our last example. So with our last example, we have f of x equal to s squared minus 1 on x minus 1. Now we are going to check if it is continuous at x equal to 1. So first step we need to do is to factorize the numerator. So with that we have f of x to be x plus 1 multiplying x minus 1 on x minus 1. Now we simplify the expression to be f of x to be x plus 1 for x is not equal to 1. Then we find the limit as s approaches 1. So f of x equal to, so we have something like, okay, let me clean this one here. So we're going to have something like lim s approaches 1 of the function 1 x plus 1. And when you do that, you should get 2. So since the simplified function is not defined at x equal to 1, we need to use the limit. Therefore, the function is continuous at x equal to 1. So if we define it as x of 1 being equal to 2. So this is the end of this video. Hit the subscribe button, like, hit the notification bell for more math videos, and I'll see you in my next video. Thank you for watching.